Welcome to August 21st's LeetCode Challenge, Sudoku Solver. Write a program to solve the Sudoku puzzle by filling into empty cells. A Sudoku solution must satisfy all of the following rules. 1. Each of the digits 1 through 9 must occur exactly once in each row. 2. Each of the digits occurring 1 to 9 must occur once in each column. Each of the digits 1 to 9 must occur exactly once in each of the 9 3x3 sub-boxes of the grid. The dot character represents an empty cell. So therefore we have this example of Sudoku board here, and we represent it like this. And then we want to solve it, I guess, in place without, and then solve it basically in place without we're just changing so we don't actually return anything. So you do not return anything, just modify the board in place instead. And then the solution, so it's basically it's guaranteed that each of the board input has one solution, and the board length and the columns are 9 by 9, and the dots or digits, right? Those are the possible constraints. Okay, so we also had, I believe, the Sudoku question yesterday as well, but let's solve it using a similar depth first search / backtracking type algorithm. So the first thing we want to do is identify all the empty spots. We're going to call this empty. It's going to be a set, and then we're going to use find to find out against a couple of things here. We're going to do rows. It's going to be we're actually do n would be the length of the list, the board, which would be 9, but we'll just solve it generically. Maybe we want to make a hash set here, so it's going to be a set of for space in range of n. And there you go. We'll do the same thing for the columns and the sub boxes. Columns and boxes. So this is pretty much the same setup as yesterday. Next thing we want to do is iterate through each of the cells in the Sudoku board, and we're basically going to recreate our board. So for I or row in range of n, I'm going to do a nested for loop for j in range. Range of n. What we're going to do is if the board at the ij location is equal to a period or empty space, then what we're going to do is append that to the empty spots set. Empty dot append the location of ij. Else, what we're going to do is we're going to append the number at the ij location to the row, to column, and to the boxes. So rows at I dot add, and we're going to add the value at the board at the ij location. Same thing with the columns at the j location. Dot add board the ij, and same thing for the boxes. Right, we want to know that we want to be able to keep track that there's no duplicate. However, the boxes, it's a 3x3, so the algorithm for that would be I floor division by 3 times 3 plus j, the floor division of j. And then we do add the board at the ij location. JK number, the value. Alright, well, this is pretty much iterating through a board and just adding if it's empty or if it's a number in our rows, number in our columns, and number in our cell boxes. Next, we're going to define another algorithm called backtracking, or backtrack. And it's going to take in a k value, which is the true. It's going to be a Boolean return. So it's true if the kth spot is filled properly. So if k is equal to the length of the spot, length of the empty row, we want to be able to iterate through return true. So if that's true, then we keep on going. Alright. So ij empty spot at k, what we're going to do is for n, let's say for, not n, for, let's see, for index, let's say for for blank in the mapping between string and range of 1 to 10. This is basically making our numbers that we're going to input into our box, our blanks. For blank not in the rows of I and blank not in the columns of J and not in the boxes category of I for division 3 times 3 plus J for division 3. If that's the case, what we want to do is update the board at the ij location to be the, I'll call this, let's just say for v for value. Alright, makes it more sense. V-val. V, and then add that to the row because now it's part of our number values that we add. Add our v columns dot add our v columns at index j, I should say. V value and boxes as well. At there. Dot add b. Now we do if statement. So if the backtrack function of k plus 1 return true, just to make it recursive, else we're gonna actually have to backtrack, right? So it's gonna be remove row at I dot remove and remove our value columns at index j dot remove value and then boxes at the index location dot remove. I'm just going to copy this. Remove. So then all this, we want to return false if it fails, and then we're just going to run our function backtrack at the 0 spot. So we'll start off at the beginning. Let's run this. Let's see if it works. Alright, let's see what I did here. So for v not in rows and v not in and v not in boxes, Oh, it's the if statement. What is this? Empty.append line 15. No, attribute J. Oh, comma. Did. Jeez. 28. Oh. Tons of errors today. Submit. Alright. So that's pretty much it. We want to make our initialize our Sudoku first. We're a backtracking algorithm to basically add all the values to the empty spots. And then if the spots meet the criteria, then we return true. If not, backtrack and then return false, and then keep on doing that over and over. So time complexity is let's see, we have a nested for loop here, so obviously there's that. Then we have this function here, which is a n value as well as a backtracking. So I would say it's like big O. It's actually very, very large time complexity. I believe it's big O of. This is also recursive as well. So big O of probably n to the third times the log of n, because every time we go through this, one number gets less and less. But that's probably an oversimplification. Space complexity, we have basically linear big O of n, because at most we have to go through each individual cells and keep track of the numbers, and we also have to keep track of the empties as well, and then we add and remove it as well. So at most it's big O of n squared for space complexity. Alright, that's pretty much it. Have a great day, guys.